Welcome to DC Economics. So today we are going to talk about the dynamic and difference equation under the concept of a COBWEB iterative solutions or dynamic economic analysis. So dynamic economic analysis, this is the branch of economics that looks at how variables adjust between the equilibrium value. So this kind of variable adjusted because there is a delay response of what is actually produced in agricultural markets. Because it takes time to raise livestock, but also it takes time to grow cash crops, because you need to plant, you need to wait after they have grown, and you need to harvest. So there is a gap of actual what is needed in the market and the actual what is produced. So this enables now to calculate different value of the variables that are adjusting to the new equilibrium level by using a spreadsheet or using a mathematical concept of difference equations. So under dynamic and economic analysis, we tend to look on how variables adjust between the equilibrium value So the models that assumes the process of continual adjustment are considered in using a differential equation. So it will be better now we understand what is the meaning of the COBWEB model under iterative solutions. COBWEB model, this refers to the fair idea, explains on how prices and quantity adjust in many markets with a delayed supply. So this is a model that tends to explain on how price and quantity adjust in many markets with a delayed supply. So in some markets, particular agricultural markets, supply cannot immediately expand to meet the increased demand. So crops have to be planted and grown, and livestock take time to raise. But also some of the manufactured products can also take a while to produce when orders are suddenly increases. So the COBWEB model takes into account this delay response on the supply side of a market by assuming that the quantity supplied now equals to the quantity equals to the what is equal to the ruling price in the previous year. So QATSC is given as the current quantity supply, and PT minus 1 is the base year price, as you can observe. Not only that, but also the current quantity demanded depends on the previous price. So the current quantity supply is called supply now, and the base year price is sometimes called the old price. So the current quantity demanded depends, is the function of the previous price. So this means that what is actually produced now depends on the previous or old price or past price of what was sold in the market at that particular time. But also another condition under COBWEB model is that the current quantity supply is a function of the base year price. So QST is a current quantity supply, and PT minus 1 is a base year price. So this is actually the reasonable picture of many agricultural markets, that the quantity offered for sale this year depends on what is actually planted at the starting of the growing season, which in turn depends on the last year price. So consumers look at the current price through when deciding what to buy. So the COBWEB model assumptions include the following: that the market is perfect competitive. That's the first assumption. Also another assumption, the supply and demand are both linear schedules. So COBWEB model faces the following limitations. And don't forget that the assumptions of the COBWEB model, this means that the demand and supply function can be specified in the format of what is known as a QDT is equal to A plus BP. And the current quantity supply is given by the function, the parameters A, C plus dpt minus 1. whereby these parameters A, B, C are given over there. A, B, C, these are the parameters of the specific function. So QDT is equal to A plus BP1, and QS is equal to C plus DPT minus 1. So when you equate out the two equations, where we obtain the equilibrium level of the agricultural market in the long run. So other limitations of COBWEB is that it must be stressed that this model does not explain how prices adjust in all competitive markets, or even in all perfect competitive agricultural markets. So it is a simple model also with some highly restrictive assumption that can only explain on how prices adjust in these particular circumstances. So this is actually the simple model with more of a highly restrictive assumption that can only explain on how prices adjust in these particular circumstances. So it is very restrictive in nature. But also, some markets may have more complex lag structures. For example, the current quantity supply may have more base year prices, as you can observe PT minus 1, PT minus 2, and PT minus 3. Or sometimes also, not only that the market may have a more complex lag structure, but also may have a linear, may not have what is known as a linear demand and supply. But also something that we should not forget is that the intervention in agricultural markets, such as EU common agricultural policies, usually means that the price is not competitively determined, and hence now the COBWEB assumptions do not apply. It will be better now we talk about the first order differential equations. It will be better now we talk about the market equilibrium of the COBWEB iterative solution, whereby the current quantity demanded is equated to its current quantity supply. So you may ask yourself, when the market is in equilibrium, what conditions are taking place? As I told you, the linear first order differential equation from agricultural long run equilibrium, we first find the equilibrium level, whereby we equate the current quantity demanded QTD and QTS. So the QTD function equation is given by A, B, PT, and the QTC is given by C plus DPT minus 1. So when we equate up the two equations, remember that DPT is minus 1, not plus 1. We divide by B both sides. So we take out A plus C, then we equate out the function of differential, first order differential equation, that is will be equals to PT, C minus A over B plus DPT minus 1 over B. So PT is actually, we call it the first order linear differential equation. And actually we use this to predict the behavior of the price of the coming years, but also as well as to oversee, also to compare on the quantity of the previous and the coming years as well. So what is the first order linear differential equation? The first order linear differential equation, this is a equation expresses the value of the variable in one time period as a function of its value in the earlier periods. So it is given now, as I told you, the current price is a function of the base year price. That is a variable in one time period and the function of the variable in the earlier period. So we sometimes call the old period. So it will be better now we go through an example. For example, in agricultural markets where the assumption of the COBWEB model applies, the demand and supply schedules are given by QADD, that is 400 minus 20 pt, and the QAS, that is negative 50 plus 10 pt minus 1. So a long-run equilibrium has been established for several years, but the one here, there is an unexpected good crops and output rises to 160. So we are required to explain how price will behave over the next few years following this one of shock to the market. But also second, to show the stability and instability of those behavior of the prices in the few years to come. But also, we need to sketch up the graph to show the above solutions. Now remember, there was a certain here where shock rises to 160, output goes to 160. But at the time where there was a shock, the question does not provide a data of what price was sold at that quantity of 160. And our intention from this question is to find out the behavior of the price of the few years to come. And actually, the few years to come, we may regard ourselves, we may assume ourselves that is consecutively maybe 3 years or 4 years. So solution, we have the quantity demanded, the current quantity demanded, that is 400 minus 20 pt, and the current quantity supply, that is negative 50 plus 10 pt minus 1. So if a shock happened at analysis of output to 160, what is the price of it? So, but also we need to predict out for the behavior of the price of the few years to come. And to our case here, we have assumed 3 years. So first of all, we need to find the equilibrium level of that long-run agricultural market before shock had happened. So we take out the QEDT, the current quantity demanded is equal to current quantity supply. So we take out 400 minus 20 pt is equal to negative 50 plus 10 pt minus 1. We take out 400, 50 is shifted to the left hand side. It will be 450, it will be 450. That is equal to 30 pt. We divide by 30 both sides. So the equilibrium price will be equal to 15. So in order we can find the quantity, we plug in the current quantity demanded equation. That we have 400, that is minus 300. Then we plug in the equilibrium price, that is 15. So the answer will be equals to equilibrium price will be equals to 100. So the current quantity demanded will be equals to 100 since we take out 400 minus 300. So since we are already solved, we have now the equilibrium price, that is 15, and the equilibrium quantity, that is 100. So we need to find out it is possible now to solve the price after the shock had happened. So if the output increases to 160, mean that the current quantity demanded at that time was 160. So we need to find the behavior, the previous price. We need to find the price at those shock of output of 160. So when we take out the current quantity demanded equation, that is 400 minus 20 pt, is where now we have the current quantity demanded at that particular year, that is 160. So we take out 400 minus 20 pt. So this will give out negative 20 pt. We shift out 160 to 400. That will be minus. So 160 minus 400, that is will be equals to negative 20 pt is equal to negative 400. So we divide both sides by negative 2. So what is known as the price when the shock goes around 160 was 12. So after knowing that, now let's come now to our key question. So that is to predict the behavior of the prices for the few years to come. Now for our case, we've considered the few years we have is 3 years. So in order you can predict for the coming year prices, we need to use the first order differential equation that predicted the current year price and basing on the old price. So from our equation, we have the QDT, that is 400 minus 20 pt. We have the current quantity supply, that is negative 50 plus 10 pt minus 1. So we equate out the two equations. So we equate out the two equations. That will be equals to negative 20 pt, that is negative 50 minus 400 plus 10 pt minus 1. Our intention here, we need to find the pt, the first order differential equation. So divide by negative 20 both sides. We find out the current price pt, that will make out the subject from the equation, is equal to negative 450 divided by negative 20 is 22.5 minus 10 pt. 10 divided by negative 20, that is 0.5 pt minus 1. So since we have the current price that depends on the base year price, now this is the equation that we'll use to predict the behavior of the price for the few years to come. That for our case here now, we've considered 3 years. So we take out the first year among those 3 years that are few years, that is P1, that is equal to 22. Now in case of plugging the base year price, we plug in the price before the equilibrium, the price after the equilibrium had occurred. That was the price where the output rises to shock, that is was 160. So we take out the price of which, that is 12. When we plug in here, we obtain the behavior of the price of the first year is 16.5. And the output will be equals to, we plug in, we take out price, we take it to the quantity supply equation. That is negative 50 plus 10 pt, plug in the value of 16.5 over there. We obtain out the quantity 1, that is 70. So we need to find the second year among those 3 years, which we have termed them as a few years to come. So we take out 22.5 minus 0.5. Now instead of putting, since we are finding the second year, the base year price will be the first year that we have already solved here, that is 16.5. So we plug in over there, we will obtain price 2, that is the price for the second year is 14.25. So the output level is where we plug in the price 2, that is 14.25, to the equation of the quantity supply equation, that is negative 50 plus 10 pt minus 1. So when you solve it, the output will be equals to 115. The same applies we do for the third year. We plug in 22.5 minus 0.5. Now we take out the base year price, that is the second price for the second year, that is 14.25, that we have solved the above. So the answer of the price for the behavior of the price will be equals to 15.375. And the Q3 is where we take out negative 50 plus 10, then times 14.25. So the Q3 will be equals to 92.5. Now after knowing that, now let's come on how we can check out the outcome for the stability or instability. Remember, under the COBWEB iterative solution, if you want to check for the stability or instability of the behavior of the price for the few years to come, we need to consider the following condition. The condition for stability is that D over B, that is D over B, is less than 1. The absolute value that D over B is less than 1. And for an unstable condition is whereby D over B is greater than 1. And for the uniqueness is whereby now D over B is equal to 1. Remember, D over B, this is a coefficient from the equation of the first linear differential equation. Remember, we are the first linear differential equation, the linear first order differential equation that enables us to predict the behavior of the few years prices. That is PT, that is 22.5 minus 0.5 PT minus 1. So since we have the coefficient that is D over B is negative 0.5. And negative 0.5, this actually means it is less than 1. So this proves out the conditions for what is known as a stability. So the behavior of the price for the few years to come was stable. So that is how it is. Now we need to consider on how we can sketch out the graph of our solution. So for our case here, we need to sketch out the graph, the COBWEB graph that's showing all the above solutions for the shock happen, for the equilibrium level, and for the behavior of the prices. So when we sketch the graph, we begin by sketching out the equilibrium level, that is having the price of 15, but also the output level, that is 100. So the graph will appear like this. So there we have the equilibrium level, as you can observe. So we have the price in the left hand side, and then we have the equilibrium price, that is 15, and the equilibrium output, that is 100. So remember, before shock happened, our equilibrium were at that point. So we draw the demand curve and supply curve that cut across. So where the quantity supply curve and demand curve cut across is at the point of equilibrium, where the long run equilibrium under the agricultural market is that the current quantity supply is equal to the current quantity demanded. Now after the shock happened, remember, the output lost 160, but also the price selling was 12. So the COBWEB model will take a picture, will depict in this way, as you can observe. So there we have 20. So will appear like this, as you can observe. So this is the output level. That is the output level, as you can observe. So this depicts that the few years to prices, the behavior of the few years to prices tends to be stable in one way or another. As well, the price increases. As well, the price increases in one level, the output after the shock goes to 160, as you can observe. So the restrictive solution showing the increasing points, decreasing points of the stability, that is CBDE, as you can observe. So at price of 15, output was 100, and at the price of the behavior of the price of the coming year was 16.5, following the same points on the level of the graph. So that is the graph, how it looks like. So here, what you need to understand is that the further adjustments as shown in the point D, E, C, and B. So the adjustment point are shown at the point of D, E, the point F, as you can observe, the point F is located over there. So these are the points of adjustment that are shown in point D, F, and etc. So that's marked the end. Welcome to DC Economics. Don't forget to watch other videos. Bye bye.